On April 13, 2029, humanity will raise its head to the sky not to admire the stars, but to witness its potential end, flying at arm's length. On this day, which ironically falls on a Friday, an event will occur that has no parallel in the recorded history of our civilization. An object capable of wiping a small country off the face of the planet or causing a tsunami that would wash away continental coastlines will approach Earth. This is not a Hollywood movie script and not a conspiracy theorist's fantasy. This is the cold, mathematically calculated reality of celestial mechanics. Its name is Apophis, the god of chaos and destruction. And it is already on its way. Every second while you are listening to these words, a huge mountain of stone weighing tens of millions of tons is closing the distance to our home. Its approach speed is measured in miles per second. It flies through the void with the precision of a sniper's bullet, and in the year 2029, it will pass so close to Earth that it will be lower than the orbits of our geostationary satellites. Imagine this picture. You go outside, look at the night sky, and see a bright star moving so fast that its movement is noticeable to the naked eye. This is not a plane, not a satellite, and not the ISS. This is a piece of primordial matter left over from the formation of the solar system, the size of 3 football fields, or the famous Eiffel Tower. Never before in the history of observation has an asteroid of this size come so close to us. Earth's gravity will grab it with its invisible hands, twisting and deforming it, causing rockfalls and landslides on its surface. But the main question that has tormented scientists and ordinary people for 20 years is, will it fly by? Or perhaps the calculations are wrong, and we will witness the apocalypse live. Today we will break down the history of the most dangerous space rock of our time. We will find out why astronomers stopped sleeping in 2004, why it was given the name of an ancient demon, and what will happen if this stony guest decides to knock on our door. The story of our acquaintance with Apophis began not with an explosion and not with a bright flash, but with a dim dot on a computer monitor in an observatory in Arizona. It was June 2004. Astronomers Roy Tucker, David Tholen, and Fabrizio Bernardi were engaged in routine work, searching for near-Earth objects at the Kitt Peak Observatory. They scanned the sky night after night, comparing images to find moving dots among the fixed stars, and they found one. The object received a temporary, unremarkable designation, 2004 MN4. At that moment, it was just another rock, one of thousands hanging around Earth's orbit. Astronomers made preliminary calculations of its trajectory, but, as often happens, the object was lost. The weather turned bad, technical problems began, and the asteroid went into the shadow of the sun, becoming invisible to telescopes. It seemed it could be forgotten. But in December of the same year, after 6 months of silence, it was noticed again, this time in Australia. Astronomer Gordon Garrad stumbled upon the same object and sent data to the Minor Planet Center. And right then, when computers combined the data from the June observations with the new December points, real panic began. Programs calculating orbits started outputting results that sent a cold shiver down scientists' spines. Usually, when a new asteroid is discovered, the probability of it colliding with Earth is 1 in a million or even less. This is standard noise in the data. But with Object 2004 MN4, everything was different. The Sentry automated monitoring system developed by NASA suddenly painted this asteroid in alarming colors. Initial calculations showed a collision probability of 1 in 300. This was already alarming, but as new data came in from observatories around the world, the probability didn't drop, as it usually does, but grew. 1 in 60, 1 in 40. On Christmas Eve of 2004, astronomers weren't celebrating. They sat at terminals, double-checking the numbers, hoping to find an error. But there was no error. On December 27th, the impact probability reached an incredible value, 1 in 37. That is 2.7%. In the world of space threats, this is practically a guarantee. Never before had any asteroid risen above level 1 on the Torino scale of impact hazard. Apophis immediately jumped to level 4. This meant a close encounter, meriting attention by astronomers. Current calculations give a 1% or greater chance of collision capable of regional devastation. Imagine the atmosphere of those days. The world had just witnessed the monstrous tsunami in the Indian Ocean, which took hundreds of thousands of lives. And against the backdrop of this earthly tragedy, scientists realized that a threat was rushing at us from the sky, capable of eclipsing any tsunami. If this rock fell into the ocean, waves would circle the globe. If it fell on land, the map of the world would change forever. NASA and other space agencies were in confusion. Should they sound the alarm? Should they tell people that in 25 years, on April 13, 2029, the world might end? Or wait for more precise data? Fortunately, the panic remained within the scientific community. In those days, the asteroid received its name, Apophis. In ancient Egyptian mythology, Apep, or Apophis, is a giant serpent personifying darkness, evil, and chaos. He is the eternal enemy of the sun, god Ra. Every night, Apophis tries to swallow the sun to plunge the world into eternal darkness. The astronomers who gave it this name were fans of the series Stargate SG-1, where one of the main villains was named Apophis, but the mythological subtext fit perfectly. This rock truly threatened to plunge our world into chaos. To understand why Apophis is so dangerous, you need to understand how it moves. Apophis belongs to a group of asteroids called A10s. These are celestial bodies whose orbits cross Earth's orbit from the inside. It revolves around the Sun with a period of 323 Earth days. This means that most of the time it is closer to the Sun than Earth, but twice a year it crosses our path, like a pedestrian running across a busy highway. The problem is that its orbit is not a perfect circle, but an elongated ellipse, and the plane of its orbit is slightly tilted relative to ours. In those tense days of late 2004, scientists tried to find archival images. This is standard practice. When a new dangerous object is discovered, astronomers start combing through old photographic plates and digital archives, hoping that this asteroid was accidentally captured in the frame years ago, but no one noticed it. Such pre-coveries are worth their weight in gold because they allow for instantly lengthening the observation arc and refining the orbit. And a miracle happened. On images from the 90s, they managed to find a dim dot that was Apophis. These new data allowed the trajectory to be recalculated, and the world exhaled. The refined orbit showed that in 2029, Apophis would fly by after all. It won't crash into Earth. A collision was ruled out. The probability dropped to practically zero. The Torino scale returned to green values. It seemed we could disperse. Happy ending. But physics is a treacherous lady. Having ruled out an impact in 29, scientists discovered a new, even more sophisticated threat. The fact is that the 2029 flyby will be so close, just over 19,000 miles, that Earth's gravitational field will act like a giant lens or slingshot. It will bend Apophis's flight path. And here a concept comes into play that makes celestial mechanics specialists twitch. This concept is the gravitational keyhole. A keyhole is a tiny region in space, a kind of needle's eye. For Apophis, this keyhole was only about 2,000 feet wide. Imagine a gate 2,000 feet wide, hanging in the void of space at a distance of 19,000 miles from Earth. If the asteroid flies past this keyhole, everything is fine. Earth's gravity will deflect it so that it goes to a safe side. But if it flies exactly into this gate, if it passes through this narrow slit, then the gravitational maneuver will change its orbit just enough for it to make a fatal circle. The asteroid will leave Earth, make a few revolutions around the Sun, and return exactly 7 years later in 2036. And then, during the second return, it won't miss. It will hit exactly in the center of the target. Thus, April 13, 2029, turned from Judgment Day into Lottery Day. We had to find out if the rock would hit the keyhole. The probability of this was small, but not zero. This kept the tension up for several more years. Scientists modeled the asteroid's motion, taking into account the influence of Jupiter, Venus, Mars, and even the Moon. But in space, there are forces that work more subtly and insidiously than simple gravity. One such force is the Yarkovsky effect. This phenomenon was predicted by Russian engineer Ivan Yarkovsky back in the 19th century. Its essence is simple, but the consequences are grand. An asteroid rotates. During the day, its surface is heated by the sun, and at night, when this side turns into the shadow, it cools down, radiating heat into space in the form of infrared photons. Photons have momentum. When the heated side emits heat, it works like a tiny jet engine. This force is negligible, comparable to the weight of a mosquito. But it acts constantly, second after second, year after year, century after century. In the vacuum of space where there is no air friction, even such a meager push can shift an asteroid's orbit by hundreds of miles. For Apophis, the Yarkovsky effect became a key factor of uncertainty. We didn't know exactly how it rotated, where its poles were, or how dark or light its surface was. Heating depends on this. Without this data, it was impossible to say for sure whether sunlight would blow the asteroid into that fatal keyhole or, conversely, push it away from it. To find this out, years of observations using radio telescopes and space telescopes were required. Radar observations allowed a 3D model of Apophis to be built. It turned out to look like an irregular potato, or, if you like, a giant peanut with two lobes. Its length is approximately 1,500 feet, and its width is about 560 feet. Only in 2021, after new radar observations, did NASA officially announce Apophis is safe, at least for the next 100 years. We know for sure that in 2029 it will not hit the keyhole. The Yarkovsky effect and gravitational perturbations took it off the trajectory, leading to the 2036 catastrophe. But this doesn't mean the show is canceled. The 2029 close approach remains a unique event that happens once in a millennium. What will we see on that day? Apophis is an S-type asteroid, silicate, stony. It consists of ordinary chondrites, the oldest building material of the solar system. Its density is high, but it is not a monolithic piece of rock. Most likely, it is a rubble pile, an accumulation of stones and boulders held together by weak self-gravity. And this loose structure will play its role during the flyby. When Apophis approaches Earth at a minimum distance, about 19,000 miles, it will find itself in a zone of monstrous tidal forces. Earth will pull the near part of the asteroid stronger than the far part. This difference in forces will begin to stretch the stone. Scientists predict that we may witness asteroid quakes. The surface of Apophis will begin to move. Boulders will roll down slopes. Clouds of dust will rise, exposing fresh layers of rock that haven't seen sunlight for billions of years. The asteroid will creak and crack, deforming under the weight of Earth's gravity. This will also change its rotation speed. Now Apophis makes a revolution around its axis in about 30 hours, but after meeting Earth, it may start spinning faster or, conversely, slow down and start tumbling chaotically. For an observer from Earth, it will look like a star of the third magnitude. It will move through the constellation Cancer into the constellation Leo. The flyby will be best seen from Europe, Africa, and Western Asia. Residents of these regions will be able to see it without telescopes and binoculars, just with their eyes. Go out into the night, look up, and you will see a glowing dot flying so fast that in a minute it covers a distance equal to the diameter of the moon in the sky. It will look like a satellite, only it won't be a creation of human hands, but a huge mountain capable of destroying civilization, flying by in frightening silence. But what if the calculations were wrong after all? What if some unaccounted factor, a collision with another small meteorite, a sudden release of gas, changed its course right now? Let's imagine the unthinkable for a minute. Let's simulate the impact of Apophis on Earth. The energy contained in this flying rock is colossal, with a mass of about 27 million tons and an entry speed into the atmosphere of about 7.5 miles per second. The kinetic energy of the impact would be approximately 1,200 megatons of TNT. For comparison, the most powerful thermonuclear bomb ever detonated by humanity, the Tsar Bomba, had a yield of about 58 megatons. Apophis is 20 such bombs exploding at one point simultaneously. The atomic bomb that destroyed Hiroshima had a yield of only 15 kilotons. Apophis is 80,000 times more powerful than Hiroshima. This isn't just an explosion. This is a planetary-scale event. If Apophis entered the atmosphere, it wouldn't burn up. It's too huge for that. The atmosphere for it is like a sheet of paper for a bullet. It would pass through the air in a few seconds, creating a shock wave of superheated plasma ahead of it. The air temperature around it would jump to tens of thousands of degrees. People who saw this entry from hundreds of miles away would go blind instantly because the flash would be brighter than 1,000 suns. And then the impact would follow. Imagine falling into the ocean. Apophis would most likely hit water, as oceans occupy 70% of our planet's surface. An impact of this scale would instantly vaporize cubic miles of water, creating a steam explosion of monstrous force. But the scariest thing isn't the steam, but the wave. A crater several miles in diameter would form right on the ocean floor, even if the depth there is great. The water displaced by the impact would form a ring tsunami. The initial wave height at the epicenter could reach hundreds of feet, possibly half a mile. This wall of water, moving at the speed of a jet plane, would begin to spread in all directions. Of course, as it moved away from the epicenter, the wave height would drop, but even reaching the coast of North America or Europe, it would remain a destructive wall, tens of feet high. Cities like New York, Lisbon, or Tokyo would be washed away in minutes. Water would penetrate deep into the mainland for tens of miles, destroying infrastructure, ports, and coastal nuclear power plants. If the impact were on land, the consequences would be different, but no less terrible. Upon hitting hard rock, all kinetic energy would turn into heat and a shock wave. A crater 3 to 4 miles in diameter and a third of a mile deep would form. Everything within a radius of 30 miles from the epicenter would be instantly destroyed by a fireball and shock wave. Concrete buildings would turn into dust. Trees would flare up like matches hundreds of miles away from thermal radiation. But local destruction is half the trouble. Upon impact, millions of tons of dust and ash would be thrown into the atmosphere. They would rise into the stratosphere and block the sun. An asteroid winter would set in. The temperature on the planet would drop by several degrees. Crops would die. A global famine would begin, which would claim more lives than the explosion itself. The economy would collapse. Civilization as we know it would receive a blow from which it might not recover for decades. Fortunately, this scenario remains only in computer simulations for now. But it's too early to relax. Space is full of surprises. Apophis is just one of thousands of potentially dangerous objects. It became famous thanks to its brightness and proximity, but there are many dark rocks we haven't found yet. The story with Apophis became excellent training for humanity, a wake-up call that forced us to seriously think about planetary defense. After all, dinosaurs went extinct because they didn't have a space program. We do. And the meeting with Apophis in 2029 will be a unique chance not just to look at the threat, but to study it point blank. The world's leading space agencies are preparing a real manhunt for Apophis. NASA has already redirected its OSIRIS-REx mission. This spacecraft, which successfully collected soil from the asteroid Bennu, and delivered it to Earth, has now received a new name, OSIRIS-APEX. It is flying to meet Apophis. Immediately after the asteroid passes Earth, the probe will enter orbit around it and begin a detailed study. It will descend low over the surface and fire its thrusters to blow away dust with a jet of gas and see what lies beneath the top layer of regolith. This will allow us to understand the internal structure of such objects. The European Space Agency is also planning its Ramses mission to meet the asteroid before the close approach and observe how Earth's gravity will deform it in real time. Why do we need this? Knowledge is a weapon. If we understand what Apophis is made of, how dense it is, how it reacts to external influences, we can develop effective protection methods. In 2022, NASA already conducted a successful DART experiment, crashing a probe into the moon of the asteroid Didymos to change its orbit. We proved we can move celestial bodies. But kinetic impact is a crude method. For loose asteroids like Apophis, it can be dangerous. An impact can split the object into parts, and instead of one big rock, thousands of small ones will fly at us like buckshot from a shotgun, which will only increase the affected area. Studying Apophis will help us understand if other methods can be used: gravity tractors, laser ablation, or painting one side of the asteroid white to enhance the Yarkovsky effect and force the Sun to move the threat aside. Furthermore, Apophis is interesting not only as a threat, but also as a resource. S-type asteroids are rich in silicates, nickel, and iron. In the future, such objects can become a raw material base for the space industry. Why dig deep mines on Earth, polluting the environment, if metals can be mined right in space? Apophis, flying so close, is an ideal candidate for the first trial resource extraction. Perhaps our descendants will look at it not as the god of chaos, but as a gold mine flying by. April 13, 2029 will be a celebration of science and a triumph of the human mind. Millions of people around the world will take to the streets to see this moving dot. The internet will be overflowing with streams from telescopes. Scientists will receive terabytes of data that they will analyze for decades. We will be convinced that mathematics works, that we can predict the movement of celestial bodies years ahead with incredible accuracy. But somewhere deep down, looking at this flying rock, each of us will feel a chill from realizing how fragile our world is. We live on a small blue marble rushing through a cosmic shooting range. And although this time the bullet will fly by, the rifle is still loaded. The story of Apophis teaches us vigilance. Space is not hostile, it is indifferent. The asteroid doesn't care if there is civilization, art, love, and plans for the future on Earth. It simply obeys the laws of gravity, and our task is to use these same laws to protect ourselves. We are the first species in Earth's history capable of preventing its own extinction from an impact from space. Apophis will fly by and go into the darkness to return in 2036, then in 2068, and so on. Its orbit will change, and calculations will have to be done again. We will watch it. We will be ready. But for now, in 2029, it will become a reminder. We are not the masters of the universe. We are just passengers who were lucky enough to learn to look out the windows and sometimes, just a little bit, steer our ship. So when that day comes, don't miss the show. Set a reminder in your calendar. Find a place away from city lights. Look up. There, among the eternal and motionless stars, you will see a rapidly gliding spark. It will be Apophis, the god of chaos who missed, the rock that could have killed us, but instead united us in the desire to know and protect our common home. Let this flyby become a symbol of our strength, not our vulnerability. Let it remind us that as long as we look up and study space, we have a future. Apophis will fly away, and we will remain. Until next time, until the next rock. After all, there are still very many of them in the universe, and the hunt for them is just beginning. This case is a perfect example of how science turns fear into knowledge. 20 years ago, the news about Apophis caused terror. Today it causes scientific excitement. We have gone from panic headlines in newspapers to calm planning of meeting missions. This is progress. We stopped fearing shadows and started turning on the lights. And this light is our telescopes, our radars, and our space probes flying through the void to meet danger, to say to it, "We see you, we know you, and we are not afraid of you." The irony of fate lies in the fact that Apophis, named after a destroyer, may become a creator. Thanks to it, funding for planetary defense programs has grown significantly. Thanks to it, new telescopes were built, such as the NEO Surveyor, specially tailored to search for dangerous asteroids. If someday in the future we discover another asteroid that will truly be flying at us, and we can deflect it, we will have to say thank you to Apophis. This god of chaos, with his frightening visit, forced humanity to build a shield. He scared us to save us. Paradoxically, but a fact, the biggest threat of the beginning of the 21st century became the most powerful stimulus for the development of Earth's security technologies. So on April 13, 2029, looking at the sky, wave your hand to it. Wave to this cosmic wanderer. He has traveled a long way to teach us a lesson of humility before the power of nature, and a lesson of pride in the power of the human mind. Let him fly further, into his cold distances. We will remember this visit, and we will be ready for any other guests that the endless black abyss decides to send us. End of transmission.